Okay, so today begins proof, and we'll start by just formally talking about a lot of the things that we do in algebra when we solve equations. So all this info on the top is for you. It's a reference so that when we start doing these things, you have somewhere to look back on. Just briefly, properties of equality are performing two things to both sides of the equation. And we know that these things work because we use them all the time. Like if A is B, then you can add C to both sides. And that's the addition property. We will refer to that as addition POE. That just stands for property of equality. So it's not just saying like addition. It's saying you can add stuff to both sides. There's a difference. One's more of a reason, to actually prove something. You can't just say addition. So you really will need that property of equality part. Substitution, you can replace. Distributive is the same distributive property we know. Combine like terms, that could be a reason when we're solving an algebra equation. Some new ones, we have the reflexive property, which is mostly unused, and it's kind of silly, but it's useful sometimes. If A is A, then A is A. Okay. Symmetric is if A is B, then B is A. Helpful when we want to maybe switch the equation around and put the left side on the right and the right side on the left. And the transitive property is really big this year. If A is B and B is C, then A is C. It's kind of like cutting out the middleman. Okay? If I said like, all my friends have $12, and if you have $12, you can buy a pizza. That's the same as saying all my friends can buy pizza. Right? So you can cut out the middleman of that $12 and, so it's kind of like just combining these together like this and then just cutting the B out entirely and then just saying, well, A is C. Okay. So that sort of like joining together two statements together and taking the ends, the bookends, like A and C, we will use that quite a bit. Maybe not today, but in the future. So this is just asking, hey, can you go from step 1 to step 2? And can you state it? And this is all we do in proofs, is we just look at one step at a time and see what's happening. So to go from here to here, it looks like we subtracted 9 from both sides. So that'd be like the subtraction POE. Because if you subtract things from both sides, if you subtract 9 from both sides, it is still equal. That's a property of equality. This one is, what do you think? How about symmetric? If A is B, then B is A. Distributive property. We know that one. We know what that looks like. When the parentheses go away and you've multiplied the 3 in. Okay? And then here, A is B and B is C. Then A, that's transitive property. Again, very useful. These things might seem obvious, like these 3 that we just did, but we're very precise when we prove things, and everything has to have a reason. So these show up quite a lot. Okay, so let's actually get into our first proof then. So just solving an equation. The given always comes first. So you're always going to copy down what was given. Okay, and if we're a little stuck, we have a reason there. It says combine like terms. So maybe I should combine these together here. So the way the reasons work is the step to go from here to here, that's what's written here. Okay? So if I just want to solve the equation, it looks like I need to prove this is x equals 5. So we can actually put this down here to kind of give us an endpoint of where to go. And to bridge that gap, I know I probably need to add 4 to both sides. And that's called the addition property of equality because I added something that's equal to both sides and it's allowed. Okay? And then to make this jump here, it looks like I did some division. Okay, so that completes the proof. So you could like rewrite this as a paragraph because you have every statement that you do and every reason for every statement. Okay, let's try that again with a completely blank one. So copy down the given, call it. The reason why I know that's true is because it's given. So with an equation, if we have parentheses and something can be distributed, I'm going to do it. So, and note that there could be more than one answer for a proof too, which makes sense. I mean, there should be more than one way to show something's correct. But normally I kind of narrow you down by giving you some hints that there's really only one way to fill in the table, which that might happen, that might not. We'll see. But this is the distributive property. Okay, and then I see that there are some terms that can be combined as like terms. So you could do CBL, or you could just write it out. Or, sorry, CLT. And to get to what I want to prove, I know that this has to be x equals 9. And then let's just double check. Well, yeah, that's correct because I can subtract 6 from both sides. Okay. So, yeah, so in class I have magnets for every single one of these reasons. Okay. So those will always be around in the classroom. You can always look around and know. And I'm including on tests. I'll leave them up. You'll know that this is one of your possible reasons. Okay. Let's move on. So now, all those questions we answered on the last test could be proved with a 2-column proof. And let me show you how that might work. So first we were given some info, and we want to prove that x is 1. Okay, and we're also given the diagram. So sometimes we'll make a statement and give a reason based on what the diagram shows us. So if this statement is that something's making a 90-degree angle, okay, I know it's 90 degrees, AOB, because there's a right angle symbol. And that's all part of the definition of a right angle. Okay. And then we see a familiar equation show up. That's a direct statement that comes from the angle addition postulate. And then once we have all that there, we know 3 things, and we have an equation for each of those 3 things. So if we want to start solving for x, we have to substitute. 90 equals, 90 plus 20x plus 16 is 126. All I'm doing is I'm just replacing each of these 3 with their expressions. And then it's just off to the races to just solve the equation and hopefully get x equals 1. Okay? So most of the time you can combine like terms from the beginning. So this is 106. If I want to get x alone, I better move this number over here, and then that's done by subtraction. And guys, when you're solving an equation, division is almost always the last thing we do. Not always, but sometimes we add or subtract last. But that's it. Okay, so some of the more difficult parts at this point might be like this part and like connecting the geometry in. But luckily I have magnets for all these things, so you'll always have a word bank of what you can use. Okay. We have a new reason here that I haven't mentioned yet, although we have talked about it, I just didn't give it away formally. So congruent segments have equal length. Okay, like fair, right? So, but that's actually a hint for the proof, because if it says congruent segments, it's likely that this is going to have to do something with congruent segments, with a congruent sign. Okay, so this was the same question from the review. Bisects. So if you're given the word bisects, in your next or maybe your following reason, you have to include bisect, because we have to convert that English word into something I can use in an equation. So I know that this has to fit in here somewhere, so I want to see if I can apply it first. Okay. Because when you did the review, you took that word bisect and then you wrote an equation about it. Okay. And the definition of bisect is AB. It cuts RT in half, meaning that RS and ST are congruent segments. This is also true for the definition of midpoint. The definition says congruent segments. And then we just have to go from there down. So this third step makes sense because it's just saying, hey, congruent segments, that's the same thing as just their lengths being equal. Remember, there's a difference between the bar, line segment, versus the length of line segment ST. Okay, and look, we were already given these lengths, and they were also written here. So it's a little bit of substitution, no? To finish it up. Substitution property. So 5x equals 16 minus 3x. And how do we move from step 4 to step 5? Whatever I do, it has to go here. Looks like we added 3x to both sides. And then x equals 2 is from division on both sides. So really, when you finish a proof, or when we finish one together, take a moment to just read through it and see kind of the flow of it. I'm never going to leave you open and give you a blank table, because I feel like that would be really challenging. I'm always going to fill in a couple things for you. So take those hints. And the big one here, it may have been hard to continue, but to know that it's going to use this fact, I knew that statement 2 had to do something with congruent segments. And I knew that was connected with bisects as well. So we'll be doing proofs with geometry for the rest of the year. So you'll get a good handle of this, but this is just an introduction, okay? So try the homework. The homework will be posted the Saturday after it's introduced. Okay, I don't post it right away because I want you guys to try it without the key, but the key will be posted at the end of the week. Okay? Thank you.